All right, so we are going to start our next unit, and our next unit is on systems and matrices. And so to get us going, we're going to review how to solve systems. You've done this in your previous algebra courses, so hopefully this is a nice review to get this unit started. All right, so again, we'll talk about linear equations and solving systems of linear equations in two variables by graphing, substitution, and elimination. Hopefully that rings a bell a little bit. Before we get going on that, I would like you to look at this right here and see if you can solve this puzzle. I'm going to pause it here and go ahead. All right. So what is a system of equations and how do I solve them? So a system of equation is simply you have an equation for a line or a quadratic function or any type of thing. We are only going to look at linear systems right now. So a system is a set of two or more equations. So you could have two, you could have three, with two or more variables. Currently, when we've talked about systems of equations, we've only had two variables. We are going to add to that since three variables will allow us to have three dimensions, and that comes into play with animation and computer graphics and things like that. So, okay, how do we solve them? Well, before we get to that, what is a solution to a system? So when we're solving systems, what are we trying to find? I'll pause it here. All right, and then how do we solve systems? There are three ways to solve them, and we are going to go over these again. One way is to graph, either by hand or a graphing calculator. Another way is through substitution, and the third way is through elimination. If you use the last two, these are algebraic forms, and you want to try to get the equation so that it has one equation and one variable left. Then you can solve for a variable. Okay, so when you are looking at systems, if you're looking at their graphs, it's kind of visually, it's easier to understand what's happening. If you have two lines and they cross somewhere, then they'll cross in one spot and you'll have one solution, like maybe 3, 7 or something like that. If you have two parallel lines, like the picture in the middle there, then here, this would be no solution because they don't cross anywhere. And then at last picture, if you have two lines that are coinciding, in other words, right on top of each other, then they would intersect everywhere. So we would have infinitely many solutions on that, everywhere on that line at least. So they would have, you would have infinitely many solutions. Okay. So we're going to go over how to solve a system by graphing. And so we're going to start with this y equals 4x plus 1 and y equals 1/2 x plus 8. Now, these are both in slope-intercept form, so that makes it a little bit easier to use graphing, and that's usually the key with these, is if they're both in slope-intercept form, I would suggest you use graphing if you can, because it's a little easier, especially if you have a graphing calculator, which is what we're going to use. So you're going to want your graphing MCA graphing calculator, the orange one, so find that on your iPad and use that calculator. Okay, so now how does this work? On your graphing calculator, you want to press y equals, and we're going to enter those two equations in there. So y equals, oh, I got these in here, but we're going to go ahead and talk about how you enter. So on the first line there, we want to enter in that first equation, which is 4x, and then the x button is right next to the alpha button. It's green. You can see now it's highlighted in red. Press that. You have x, t, theta, and n. That'll give you x. And then plus 1. And our second equation is y equals 1/2 x plus 8. A reminder with this calculator, it's important that you put fractions in parentheses. Sometimes it'll work if you don't do this. I would not gamble. I would always put fractions in parentheses. So 1/2 x like that, and then plus 8. Okay, so now you have your two equations, and it will graph both of these. So you're going to press graph next. All right, and now at this point, you should be able to kind of see about where that intersection is. To me, it looks like maybe 2.8 or 2.9, somewhere in that neighborhood. So we want that to be precise, though. So you're going to look at right above the trace there, you can see in blue it says calc. We want to find that exact calculation of where they are. So you're going to need that second blue button there, and then press trace for calculate. And now it should give you that screen right here. And we want to know, where do these two lines intersect? So we want that fifth one down. So you can either scroll down or you can just press 5. I'm going to press 5. And it'll give us this screen. It'll put a cursor on one of your lines. This is because sometimes you might have more than 2 lines, and it just wants to know which 2 do you want me to look at. So we want that one. So you're going to hit enter. And then you're going to hit enter again because it'll say second curve. Yep, that's my second curve. And then it'll say, do you want me to guess? You're just going to scroll through that by hitting enter again. And at this point, it should say at the bottom of the screen, intersection, and give you where those 2 lines cross. So the point that they both have in common is the point 2, 9. So 2, 9, and we are going to write that on our paper here. And it needs to be written as an ordered pair. So you're going to go in parentheses 2, 9. And there we go. All right. So now what I would like you to do is try this second one. And the second one says y equals 7x plus 8. And y equals negative 5 fourths x minus 9. So take a second to do that and put that in, and then we will go over it. All right. How did we do? All right. And then this is the steps for that, in case you need that and you want to review. You just can't remember that as you're going through your assignment. Those are the steps to do those kinds of problems for graphing. Okay, hope that helps, and hopefully that's a good refresher for you. Or if that's new, this is new to you, I hope that this makes sense. All right, we'll see you. Bye.